sec. Okay, I think we're recording now. Now, remember the last time, the rational function we did the last time. Can somebody remind me the difference between that and this particular one?
Last time the rational function, the top is linear. This time talk is about quadratic.
That's it. So this time around it's been flipped. So in your worksheet, I call them proper and improper fractions, if you noticed. Okay, a proper rational function would be the one such that the degree of the polynomial at the numerator is strictly less than the degree of the polynomial at the denominator. Okay, any other one is improper. Even if the degree of both numerator and denominator are the same, like linear over linear that we have done in the past, that is also improper. Okay, the reason I said that is also improper is this. Let me show you something before we proceed with this one. You will recall during our general class, even with the SL friends, we had something like this. We had something like x minus 1 divided by maybe x plus 1. Remember? Then we will often say we want to put x plus 1 first. And how do we get our minus 1 back? This has to be minus 2 divided by x plus 1. Then we split it. We split it this one, then also this one. So that we have x plus 1 divided by x plus 1 minus 2 divided by x plus 1. Do you remember this?
Yes.
Okay, and this will be 1 minus 2 divided by x plus 1. So basically, we are expressing a fraction in a mixed form. So it's like giving you 3 divided by 2, then you express it as 1 plus 1 over 2, something like that. Okay? The only way you could express something like this where you have a whole number is if the original problem is an improper fraction. So yes, even if the numerator and the denominator have the same degree, it's still not a proper fraction. Okay, then we realize, if I may add, that this guy standing alone is always the y asymptote. Because your y asymptote, your horizontal asymptote, sorry, your horizontal asymptote is what happens as x tends towards infinity. Okay, when x tends towards infinity, this whole fraction becomes 0. When x tends towards infinity, this denominator tends towards infinity, and the entire fraction tends towards 0. So it means everything which is y from the beginning, it means y tends towards 1 because this tends towards 0. That is why this is our horizontal asymptote. Understand? So that is the idea of the improper fraction. So in your worksheet, I call that an improper fraction of the form of quadratic divided by linear. Okay, so thank you, Alex, for that. Now let's look at our decimals and answer this question. So the first one, x squared minus x minus 5, x minus 5 at the bottom. So we have x squared minus x minus 5. I'm sure this is what you get. Now, the question says, state the equation of the vertical asymptote. Yes.
X minus 3 at the bottom. We put x minus
oopsie, like that. Thank you. Thank you, Mr. Yanko. Let me try to use, I like to use this bold one so that it's clearly visible. Okay. Okay. We are almost there. Now, I think by the side is better. Okay. So from here, what is our horizontal? I think the first question is to state the equation of the vertical asymptote. Yes, anyone? I think it's obvious. What is that?
Yes, x equals to 3.
X equals to 3. Let's see if we plot x is equal to 3. Okay, that is definitely our vertical asymptote. The next question, show that this is equal to this. This we will do by division of polynomial. So because we have done division of polynomial, we will first review that in a few minutes. So this can be done. Then it says use the technology to sketch this and this on the same axis. So now let's sketch y equals x, that is this line. Okay, this one by the side. After you have shown this is equal to the same as this. It's similar to what I just showed you on the board. Okay, except that you use division. Do you remember division of polynomial? You divide x by the first term, you multiply everything, you subtract. Remember when we did polynomial, long division? We will review it again if you have forgotten. So that's what we're going to use to do this. So let's plot this 2. Now this has been already, so let's plot y is equal to x plus 2. You don't have to put y is equal to. Just say x plus 2. Okay? Now, explain why this approaches x plus 2 as x tends to infinity. Explain why the graph of this approaches this as x tends to infinity. What do you say? Anyone? That's the slant or oblique asymptote. That's exactly the idea that we're trying to study here.
Okay.
Remember, we have vertical asymptote. So far, we have done vertical asymptote, horizontal asymptote. Now this is slant asymptote. Why is it called that? Because it's in slant form.
Yeah.
Okay, so that is the line that the curve never reach as x becomes large, either on the negative side or on the positive side. Does that make sense? So that line x plus 2 is the slant asymptote to that rational function. Any questions, please?
No.
Questions? Nope. Okay, now let's go to the next one. Consider this. So let's plot that on the same axis. Let's get this off. 6 over x. Okay, so we have 6x squared minus x minus 3. 6x squared minus x minus 3. Then divided by x plus 1. 2x plus 1. That's what we have. Then the first question, yes. What?
Plus 1 at the bottom.
Again, thank you for watching my back. Okay. We have this time. Now, show that state the equation of the vertical asymptote. What is it?
Negative 0.5.
Negative 0.5. That's wrong, Alex. Can somebody tell me why I said it's wrong?
Use fraction, not
Have to use
decimals.
fractions.
You don't have to use fraction.
Oh, he didn't say x equals 2.
He didn't say x is equal to. So if I write here negative 0.5, let's see what happens. Nothing happens, Alex. If you don't use x is equal to, how do you tell the graph that you are referring to the x-axis or y-axis? Okay, so you must not leave that out. Again, we will use division of polynomial to do this. Then let's sketch this one by the side and say 3x minus 1. Y equals 3x minus 1. Is it minus 1 or plus 1? 3x minus 1. Okay, so why does it cross it? Yeah, maybe at infinity, it doesn't touch. So again,
Mr. Daniel, on my graph, 3x minus 1 works.
so what can somebody check what I've done wrong? Oh, plus x, not minus x here. Yeah, that's what I should get. So if I try to, you see? Okay, can you see that? So again, that is your slant asymptote. That is your slant. Let me see if Elson is knocking on the door. Okay, it's not. So we can let him into the room. Does this make sense, guys? So basically, what can you tell me? I want you to be the one to tell me the process now. If you are given a rational function, let me go back to the book. If I are given a rational function of this form, okay, how do I get the vertical asymptote and how do I get the slant asymptote? And is there anything like horizontal asymptote? Anyone?
First, you would look at the denominator and equate that to 0 to make the vertical asymptote. And then you would do division of polynomials. I can't say the word right now.
Yeah. You use division of polynomial, yes.
Yes, to find to
quotient.
calculate the final quotient.
The quotient.
And then that would be the slant asymptote.
You guys get that?
Yes.
Alex?
Mm-hmm.
Okay. Now it says here, describe the behavior of this graph as x tends to infinity. Look at it. As x tends to infinity, what can you say about this graph? As x tends to infinity means as x becomes large. So you see, when x becomes large means as you move towards this direction. Okay, the graph is somewhere there. Trust me. So as you move towards this direction, the question is, what can you say about the graph? You can see my x is already 500. Say that again.
The graph tends towards the line x, the 3x minus 1 from below.
Do everybody understand that?
Yes.
As x tends towards infinity, the graph approaches the line 3x minus 1. Okay? The graph approaches the line 3x minus 1. That's all you have to say. Question, please.
No.
No questions.
All right, so I'm trying to get back to normal. Okay, yeah, that's it. As x tends towards infinity, the graph approaches the line. So either way, both positive and negative infinity is the same. Okay? Then it said something like from below. Yes, it's right. If we're talking about this side. And for the other side, it approaches it from above. So yes, I like the way you put it. If I'm to test this, maybe in a test or anything. Oh, it's actually said absolute value of x tends towards infinity. Did you see that? So it's not just the positive one. So it's both of them. Okay. So here you can be silent about from below or from above if you want to combine a single statement. But if you want to write it separately, as x tends towards positive infinity, then you can include your from below. As x tends towards negative infinity, you can include from above, something like that. Understand? So this is it. So you see, we call it oblique or frontal asymptote. Not yet. Okay. I want you to. Okay, can you see? Can you see the top? So this is the question I just asked you. To help describe this graph, we use the polynomial division to write in this form. So that's the first step. Okay, the function is undefined when this is equal to 0, and that is your vertical asymptote. Okay, as x tends towards infinity, this fraction tends towards 0, like we said. Do you remember that? Yeah. And so the graph gets closer to this line, which is the quotient. So this graph is the oblique or slant asymptote. You can call it slant asymptote as well, but you can use the word oblique more. Are any questions?
No, not so far.
All right. So what we need to try to practice first is division of polynomial. Can I please ask you to do this just as a review? Division of polynomial. Before we do that, let's write officially what we are doing today. Today is what? Yes.
Get a cup of water.
Yes, please. Get whatever you need to get. Today is 9, right? 9th of
Yes.
May. Okay. So what we are trying to study is of May, Sunday. I just call it improper rational function. Something like that. A and D non-zero. I think it's a Q, not a G, sorry. So these are the two things, and of course, maybe sketch the graph. Proper rational function. Good. So these are the three ideas we are compressing, trying to look at today. So from the investigation, observation now. From the investigation, 1, y is equal to ax squared plus bx plus c divided by dx plus e does not have what?
Horizontal asymptote.
Horizontal asymptote. Thank you, guys. Does not have a horizontal asymptote. If y equals to ax plus b plus bx plus c divided by dx plus e is expressed as y equals to px plus r plus, there will be a number at the top, maybe px plus q, then r over dx plus e, then the line y equals to px plus q is the what?
The oblique asymptote of the
Thank you, Yanko. Oblique asymptote of what?
of the graph.
Graph. I said of the graph because there are two graphs now. So can we say of the curve?
Okay.
Okay. Maybe before I write that, okay, I can combine it. Because as absolute value of x tends to infinity, okay, the curve, the rational function tends, as absolute value of x tends to infinity, r over dx plus e tends to what?
Zero.
0, tends to 0, and consequently, which implies that y tends towards px plus q. So maybe I call this y1, this is also y1, then this will be y2. So we will say that we're saying y1 tends towards that. Understand?
Yes.
So it's just a summary of our investigation. So the procedure will be to divide using polynomial division, to put it in that form. We will also study the behavior as it approaches the vertical asymptote so that we know the shape of the graph. Apologies. Okay, I'd like to move to the book. Okay, so everybody pay attention.
Actually, can you go back really quickly? I have one last thing to copy.
Okay. Just like that. Let me know.
Okay, I'm done.
Done. All right. Can you see this example?
Yes.
Yep.
Okay. So let's watch this and see how we can sketch. Especially for paper one where calculator is not allowed, you need to understand this. So please note that nothing is new. The only new thing is what we have just discovered in the investigation. Every other thing is based on whatever knowledge we must have acquired from different topics. Mr. Elson is knocking on the door. Come in. Mr. Elson. One sec, guys. Mr. Elson is here. Mr. Lam is here. What is wrong with this video? I need to know if you are ready, Mr. Elson. I need to move on.
Yes, I'm here.
Okay, finally made it. Okay, we did an investigation. You get to see that later. I'm sure you can catch up. So let's move on. So again, like I said, the only new thing is the result of that investigation. Every other thing is based on what we have done before. For example, the vertical asymptote is based on what we have done before. The axis intercept is based on what you have done before. So like the x-intercept is when y is equal to 0. And when y is equal to 0, it is when the numerator is equal to 0. So which means there will be two values there. Okay, and that is your x-intercept, right? X-intercept is when y is equal to 0. So it means it crosses the x-axis at 2 points. The y-intercept is when x is equal to 0, which is just going to be the constant over constant minus 9 over 2. That would be 1 point. Oblique asymptote is based on your division of polynomial that we have just done. Taking the quotient part, that's your oblique asymptote. Okay? To draw the Sine diagram, you will see it's based on what you have also done before. Discussing the behavior near the asymptote. So you discuss the behavior when it's coming close to the asymptote, I mean the vertical asymptote especially, understand? And when it's moving away, okay? And there are two asymptotes this time. So you want to talk about approaches from below or from above. Do you understand? To discuss the behaviors asymptote, if you remember what we did before, we will often talk about when it's moving close to the vertical asymptote from both directions, and then when it's moving away from it. So when it is moving away from it, it's when it's approaching either the horizontal asymptote or this time around the slant asymptote. Am I making sense? So it's still the same procedure that we have done before. Okay, then with us, all this information, then we can sketch the graph. So I want you to listen to the instructor here, and thumbs up if you can hear the audio.
We have already studied rational functions of the forms linear over linear and linear over quadratic. We now consider a rational function of the form quadratic over linear. These functions have oblique asymptotes, which are neither horizontal nor vertical. In this case, the function is undefined when the denominator is 0, which is when x equals -2. So, x equals -2 is the vertical asymptote. We find the y-intercept by substituting x equals 0. In both the numerator and denominator, the only non-zero terms are the constants. So, the y-intercept is -9 over 2.
You have to explain like that.
X-intercepts can only occur when y is 0. So, the quadratic numerator must be 0. We solve this equation by factorization. 2x squared is 2x times x. Then we search for a factor pair of -9, which gives us the correct middle term. The numbers we need are -3 and 3. We hence solve the equation and find the x-intercepts are 3 over 2 and -3. To find the oblique asymptote...
Sorry guys, the audio is being delayed.
2x squared is 2x times x. Then we search for a factor pair of -9, which gives us the correct middle term. The numbers we need are -3 and 3.
You do it the way you know.
We hence solve the equation and find the x-intercepts are 3 over 2 and -3. To find the oblique asymptote, we need to perform the polynomial division represented by the fraction. We first set up the division. To get 2x squared, we need to multiply x by 2x. The product of 2x and x plus 2 is written underneath, and we subtract it from the quadratic.
I hope you remember this. You first divide the first term by the first term, right? So that's 2x squared divided by x. This must be arranged in descending powers of x. So x raised to power 1, x raised to power 0 term. X raised to power 2, x to power 1, x to power 0 term. If any term is missing, what did we do during polynomial class?
You put 0.
You put 0 term. So you have 0x, for example. Okay? So just to keep the space, because when you do your first division and you get the result, you have to multiply by both of them. Okay? So 2x squared divided by x gives 2x. Then you multiply this by both of them. So that is 2x squared and 4x. And that's what you have. So if you have not left a space for x because it's missing, it will be difficult to divide without any mistake and subtract without any error. So we always leave a space. We did that during polynomial division. Okay, so you subtract, you get minus x. As long as the degree of this is still the degree of this, you continue to divide. You only stop when the degree of your subtraction is strictly lower than the degree of your divisor. I mean your remainder here. Okay, I don't want to call it remainder because that's not the final remainder. Okay, so then you go through the process again. Minus x divided by x. It is always the first term divided by the first term in the divisor. And that will give minus 1. Then you multiply. Minus x and minus 2. And when you subtract, you get, I think, minus 7. Alex, you are restless. So that minus 7 will now be the final remainder. Because you cannot go further. Who can tell me why? When you subtract, you get minus 7, you cannot go further.
Because there's no x in that.
That's
remainder.
not the appropriate term. Even when there is x in the remainder, it doesn't mean you can go further. In some cases, even if there is x there, you still have to stop. So that's why that is an unacceptable response.
The remainder has a lower power than the divisor,
Lower power,
or lower degree.
lower degree. Thank you. Lower degree. Because if you're having a quadratic, you stop at linear, which contains x. That's why I won't accept that else. Understand?
Yeah.
So let's proceed. I just wanted to mention this so we can remember what we did in the division. So we don't have to waste time doing that separately. Would that be okay with Alex? Yanko?
Yeah.
Okay, let's move on.
To get minus x, we need to multiply x by minus 1. The product of minus 1 and x plus 2 is written underneath, and we perform the subtraction. We are left with the constant remainder, minus 7. So we can write the function f as the linear quotient plus the constant remainder over the divisor.
So the same way when you're doing it, can you put this on one side while you arrange this on this side like this? It's okay. But let there be space so that I know the difference between this one and this one. Okay? You do your division, then you write the original function is now in the form of a mixed fraction. The whole number in quotes, then the remainder, which is minus 7, so there will be negative in the middle. If the remainder is plus, then this will be positive, divided by the divisor. I hope this makes sense to all of you. All right.
As x tends to plus or minus infinity, the denominator will dominate, and so the fraction tends to 0. So the oblique asymptote is the line y equals 2x minus 1. To construct the Sine diagram for the function, it is easiest to write the function in factored form. We have already factorized the numerator in part B. The critical values include the x-intercepts 3/2 and minus 3, and the vertical asymptote.
Again, the Sine diagram is what happens on the x-axis. So every critical point on the x-axis must be mentioned. And the set of critical points here will be the vertical asymptote and the x-intercept. That's why the 3 are there. Now the asymptote must be in broken line. So that means that is where the graph cannot attain any value of y. Am I making sense? So it must be broken line. But here, the values of y exist. That's why they are thick lines. Please take note. Of course, you don't have to measure. Okay? Just write to a random point in order, please. Let's move on.
At minus 2. When x is large and positive, both the numerator and denominator are positive, and so the function is positive. Each factor is single, so the signs alternate.
Okay.
The Sine diagram helps us describe the behavior of the function near the asymptotes. Just to the left of minus 2, the function is positive. So as x tends to -2 from the left, the function tends to infinity. Just to the right of -2, the function is negative. So as x tends to -2 from the right, the function tends to -infinity. To consider the behavior sign diagram helps us describe the behavior of the function near the asymptotes. Just to the left of -2, the function is positive. So as x tends to -2 from the left, the function tends to infinity. Just to the right of -2, the function is negative. So as x tends to -2 from the right, the function tends to -infinity. To consider the behavior of the function as x tends to plus or minus infinity, it is easiest to go back to the quotient and remainder. As x tends to -infinity, the denominator is negative, and so the overall remainder is positive. The function tends to the oblique asymptote from above.
Let's look at that again. When x tends to negative infinity, just pretend you substitute negative infinity here. Negative infinity plus 2 is still negative infinity. And there's a negative here. Okay? So that means it approaches 0 from above because of minus and minus gives you plus. Okay? And if this, can you see the cursor? Can you see my cursor?
Yeah.
If this approaches 0, it means everything approaches 2x minus 1 because this has become 0. Don't ever think of substituting x is infinity here. No. The idea is to make this 0. Okay? Again, when x, just pretend you are substituting, although you cannot substitute. Substituting x is equal to negative infinity. This is going to be negative infinity. Then there's a -7 at the top. That becomes plus 0. That's why we say it approaches 0 plus. And we pronounce that 0 from above. If it approaches 0 from above, now this has approached 0 from above. It means everything, f of x itself, approaches 2x minus 1 from above. That's why you have this. Okay? Similarly, for plus infinity, everything here becomes plus infinity. Right? Which means the entire fraction becomes 0 minus.
Yeah.
Are you with me? It means the function approaches 2x minus 1 from below. Because you need to know, if you are going towards infinity, does it approach the oblique from below? From below means it's coming down, approaching it. All right? Or is it approaching it from above? It's coming down and approaching it. You have to know. Understand that? Aha. So listen.
As x tends to infinity, the denominator is positive, and so the overall remainder is negative. The function tends to the oblique asymptote from below. We now use all the information we have gathered to draw the graph of the function.
Elson is not listening.
The vertical asymptote is x equals -2, and the oblique asymptote is y equals 2x minus 1.
Can you see that? You take note of those ones, then you take note of the intercept next.
We mark the x-intercept and y-intercept. We next mark what happens near the asymptotes.
See, now let's look at the first one before we play it. When x approaches -2 from below, -2 is this line. From below means in this direction. We are saying that the graph approaches infinity, which means when x is coming this way, the graph is going up. Okay, now listen to that.
Either side of x equals -2, and as x tends to -infinity and plus infinity. We can now connect this information.
Can you see that? When it's coming from this side, the graph is going up. Remember, it cannot touch it. So you know that, oh, there will be, so if I'm sketching it, I'm going to start by sketching this one first. Okay, I go up that way, it doesn't touch. Then I look at the second one, when it's approaching -2 from below, from above, which means when it's coming from this side. When it's coming from this side, it says it's going down. When it's going down, it still does not touch this. So it means you can sketch this part. Again, I have only sketched this part and this part. Sketching this part, I know it's going to pass through here. It's going to pass through here, okay? And sketching this one, I can start from this one. I know it's going to go up like this. Hello? Then I look at the other one. Negative infinity means now if I turn to this direction, then it says, oh, it's going to touch the line from above. It means it's going to, the line is below it. So it's coming from above, trying to approach the line, but it does not approach the line. Coming from above, which means the continuation of this sketch. Are you with me? Similarly, when x tends towards infinity positive, which means when x is going in this direction. Okay, when x is going in this direction, it is going to approach the line, there's oblique asymptote from below. It means it's coming, you remember, we have only sketched this before, and we stop here. So it's going to come from below, passing through this mark, and trying to touch the line. And that is how to sketch it. Understand?
Yes.
Okay. Let's see, anything else?
Using
Yes.
two smooth curves. Remember that a graph can never cross a vertical asymptote, so the graph must have two separate branches.
Okay. Now that is sorted, let's see. I'll send you a screenshot of this if you want. This is in your book, right? In this worksheet that I gave you. I think that's question 1 in the worksheet. Check. Come on, come on, come on, come on. All right. So everyone in the space provided in the worksheet, do this question 1. So while you're doing that, I'm going to be sending this screenshot to the group so that you can put in your notes. Also, I will send this investigation as a screenshot as well. You can try it as you watch the video later. I will encourage you to please watch the video later. You probably understand what we did, but at the same time, you might just learn a thing or two from our discussion.
Okay.
We want a single screenshot. It's going to be small. I'll send that as well. I don't know how many of the questions here I put in your book. So I'll send this number 2. So if there is any question I didn't put in your worksheet, you can take from here to practice. Extra questions to practice, if not in the worksheets. So on Wednesday, I want you to prepare for rational function test for the second period.
Can you say again, please?
For the first period, I told the whole class you're gonna have something on regression, right?
Yes.
So for the second period, the rational function that we did before and this one only.
Okay.
Okay?
So just these two forms.
Just those two. Rational function, linear over quadratic, then quadratic over linear. Okay, for the second period on Wednesday. Understand?
Yeah.
Yeah. Mr. Daniel, is this
Yes,
is the worksheet the one that Candy gave us?
yes. That's the
I
one we are
left
doing
mine at
right now.
school. I left mine at school, Kat.
Uh-oh.
I'll finish it. Yeah, sorry.
Let me see if I can find the soft copy. You lazy boy.
Very, very sorry.
Improper. Okay, found it. Let's see. It's actually online. I told you I always put it online now.
Oh, right, yes.
Let me see. Improper. Graded task. I think that is, yeah, page 4, 1 to 4. Okay, let me send that to you on WeChat. You're welcome to print it yourself. You want to. Yeah, thanks. If you want to print that, or you can do it tomorrow in school and just use whatever I send to the group. So I can send you the picture in the book if that's the one you want to do now. So from the book, this is the question everybody is doing. If you want to work it in your notebook, it's fine. And do your worksheet later, your choice. I send that to the WeChat as well. Or you could use whatever I've sent to you and print it yourself. Yeah. I'd like to see some replies on WeChat, just from 1 or 2 people. Whatever you have done, send to me, because I'm going to close the meeting in about 3 minutes. And please work together for the rest. So to avoid reading, avoid recording unnecessary parts, I'm going to close the meeting now, and I'll be expecting your answers on WeChat. Just send me a picture of whatever you are able to do.
Could you wait 1 more minute, because I'm basically done, and
Okay.
we're at the conclusion to last question.
So, okay, got something? Mr. Yanko. Let's go asymptote. You said vertical asymptote is equal to x minus 1. That's wrong.
No, I put at the bottom x equals to 1.
Then you're confusing us. You don't expect us to understand what you meant. You can say vertical asymptote is, hold on, sir. Vertical asymptote is when x minus 1 is equal to 0. That makes sense. You must, can you mute yourself, please? Vertical asymptote is when x minus 1 equals 0, which means when x is equal to 1.
Okay.
Understand? That's better. Don't write vertical asymptote is equal to x minus 1. Then in the next line, x is equal to 1. It's quite confusing. Your axis, you said y-intercept x is equal to 0. Are you saying y-intercept is x is equal to 0?
This is when x equals to 0.
Exactly. So put the word when. Don't use double column. Y-intercept is when x is equal to 0. Then you can work out whatever you have worked out. Similarly, x-intercept y is equal to 0. That's also another miscommunication. X-intercept is when y is equal to 0. Then you can jump to when the numerator is equal to 0 and you get that. This is wonderful. So what else? I ask you to do that. Okay. Let's see your division of polynomial. Good. You have -2 there. Then you have -2x plus 2. Is it +2 or +3, Yanko? Second to the last line of your division of polynomial.
It's +3.
Why do you get +3? It should be -2 times -1.
Oh, right.
So that's the
Mr. Daniel, don't look at my message. I have found so many things that are wrong.
Right. So I think that's the only thing, Yanko.
Yes.
What else? Is that all? Is it just 3 questions? A, B, C?
And then it will be question 2 at the back.
Okay. All right. Well done. So far. Too late, bro. I see your question. It's rubbish. Kidding.
I think I did it wrong at the top too. I put -3.
You mean your subtraction?
Yeah.
So please always. So let me check that. -3x squared, you get 3x. 3x times that should be 3x squared minus 3x. Yes. So it should be -3x, not +3x.
Yeah.
Right? And when you subtract with the minus outside, I should be getting 4x, not -2x after your subtraction. All right. So if anyone has forgotten how to do division of polynomial, I suggest you look at your notebook and watch the polynomial division video, which is online, just for review, because that will be an integral part of your test as well on Wednesday. Okay, new message coming in from Mr.
This one should be better. Hopefully.
Right. Find the equation of the horizontal. Okay. All right. X-intercepts, you just wrote 2/3 minus 1. No, you don't write like that. You don't write like that. Is it x is equal to something? Is it y is equal to something? The same way you wrote f of 0 is equal to 2. Can you please write y is equal to 2, something like that? Okay. And after your division for x, I can say the minus brackets. Please put that to avoid any mistake. It's just to reduce your errors, sir. Okay. Okay, I think that looks good. The slant asymptote is that. So that's it. Okay, another message, Mr. Alex. Mr. Alex. Vertical asymptote is when x is equal to 1. No. What do you mean vertical asymptote is when x is equal to 1? What does that mean? You only listen to the part when I say when x is equal to. You were not listening to the context when I was discussing with him. Vertical asymptote is when x minus 1 equals to 0, which gives when x is equal to 1. which gives x is equal to 1. So you don't write vertical asymptote is when x is equal to 1. You are trying to make it look like when x is equal to 1, something happened. Nothing happened. X is equal to 1 is the asymptote that we are talking about. Understand, sir? Good. So you should change your wording there, even though I get what you mean, but it's not acceptable. Now, when y is equal to 0, you do that, x-intercept, this and that, perfect. When x is equal to 0, you did that, y-intercept is y equals to 2. You can write that on the straight line. Instead of y-intercept is on one line, then y is equal to 2 on another line. So you see, this makes sense. Y-intercept is x equals something. X-intercept is x equals something. That makes sense. Not asymptote is when, no. When x is equal to 1 minus 1 equals to 0, which means x equals 1. Okay. So your division of polynomial looks good, and your oblique asymptote is correct. Well done. Okay, that will be all. Continue your work and practice among yourselves if you can. Tuesday will be dedicated to trigonometry. The whole class will start trigonometry on Tuesday because we have just finished the correlation and regression. And Thursday as well. Then we will just review some of the IGCSE concepts like the sine, cosine. They are part of the general syllabus. Then we will start our own trig for the HL. Okay. The idea is by the end of the academic year, we have done topic 1, topic 2, topic 3, and part of topic 5. So when you come back in from 6 September, it should only be topic 4 and topic 4 and topic 5. Topic 4 is statistics and probability. Topic 5 is calculus. And usually I calculus first before probability and statistics, because I don't want to go back and forth. So I like to do integration and differentiation. Plus in statistics and probability, there is something called probability distribution for continuous random variable, which requires integration. So I like to make sure I do that before. Okay, I like to do calculus before that. Okay, and I'll be talking to Mr. Lon to hand over some of the things that I have done and I have not done, and we're going to finalize again about the support that I mentioned, and so that we can still have some meetings, especially with you HL guys. Okay, all right, see you guys on Monday. Enjoy the rest of your weekend. Bye. Bye.